Hello. So why we think that past and future are very different in equations, especially so-called CPT theorem, they seem very similar. So I will try to discuss this problem. So generally, if you have symmetry in equations, for example, in of this lake, which is symmetric in equations, we can break it by just throwing a rock. Yeah, so symmetry in equations can be, it's no problem to validate them in a solution. What was this rock for our asymmetries? So for example, Big Bang was everything was localized, so entropy was low, suggesting it was this rock starting asymmetries of our universe. So one asymmetry is the second law of thermodynamics, entropy growth, well known. But there is also second, also very important, but usually neglected, so-called asymmetry of radiation, for example, by Hugh Price, that circulating electrons or masses now many lose energy in spiraling. Yeah. And the explanation seems to be just that now there is domination of absorbers over emitters. Yeah, so but we can change it. For example, there are these tabletop accelerators with laser adding energy to electrons. So adding more emitters, we can change it. We can make it opposite that electron gains energy, not loses. Yeah, so this seems again a property of solution that now there is more absorbers than emitters. So regarding the entropy, for classical evolution, it is deterministic. We have some particles, and there is no entropy. We have just one classical solution. Entropy is zero. To get the entropy growth, for example, in Boltzmann-H theorem, there is introduced approximation, mean field-like approximation called Storch-Zelen-Satz, which, for example, replaces these classical point particles with a probability of being in the, let's say, left containment. Yeah, so we smear the particles into the entire halves of the containment. So this is this approximation, this is effective description of our knowledge. And doing this approximation, we can show that entropy should go to 1/2 because this number of possibilities for p equals 1/2 is the largest. Yeah, so just entropy maximization says that the safest assumption is that there is 1/2 on the left, 1/2 on the right, because it grows, because it's the largest number of possibilities. Yeah, so but we have to use this approximation. However, we could first apply the time symmetry and then use this approximation, and this way we would get the entropy growth, but in the opposite time direction. Yeah, so finally there should be this tendency for entropy growth. In fact, it should work in both directions if you have a low entropic state. And for example, in this article for quantum thermodynamics, it's summarized as that system is dissipative and decohering in both temporal directions. Yeah, if you have a low entropy, a coherent situation, and try to evolve it in both directions, time directions, we should get the coherence entropy growth. Yeah, so in fact, the entropy growth is not asymmetric, but it is also symmetric, this tendency for entropy growth. So let's think about the time philosophy. And generally, the mainstream says that only what has remained is the unification of general relativity with quantum field theory, standard model, and both are CPT or time symmetric. So if we switch time, they are very similar. Yeah, so the equations are the same. So there are these two philosophy of time. One is called presentism, and it's intuitive for us that there is three-dimensional situation and it evolves in time. However, both this general relativity instead works on four-dimensional space-time. So it's called eternalis, Einstein's block universe philosophy of time, that there is some four-dimensional solution, and we just travel to this already found solution. So these are completely different philosophies. And general relativity does not work for this evolving 3D. It's not like that the space-time which evolves its shape. No, we have just four-dimensional space-time which satisfies Einstein's equations. So kind of minimizing minimizing tension from both directions, like four-dimensional jello. And this is actually also for quantum field theorists. So they work on Feynman ensembles for this scenario. So no longer just one shape of space-time, but the Feynman ensembles. So again, it's crucial, absolutely crucial to work on four-dimensional scenarios. I will show in a moment why. So in this four-dimensional case, for given moment in time, we get kind of tensions from both directions. Yeah, so this tension is, for example, known in scattering matrix as matrix, that there is one amplitude going from one direction, second from the other, and they meet, and we need to multiply the two amplitudes, what's called the Born rule. So this is very, very fundamental for quantum mechanics, this Born rule, that is extremely non-intuitive, because so what for us is intuitive is so-called Kolmogorov that axiom, that having alternative of two events, the probability is just sum of alternatives, sum of probabilities. In contrast, physics allows to change it into Born rule, where we first add amplitudes, then take square. So this is completely different rule for the same question. So now if we derive inequality based on this inequality, this Kolmogorov axiom, and switch the answer to the same question into Born rule, we can violate this kind of inequalities, like Bell theorem. So it's crucial that we go switch from this intuitive presentees to eternalized block universes as required by Bell violation. Yeah, so there are two different philosophies, and there are many experimental arguments that it's crucial to use this eternalized block universe, that there is already found four-dimensional scenario, and we just travel through it. Okay, so let's think about this Born rule from time symmetry, like in scattering matrix. Yeah, so imagine this infinite potential well, that we have just a segment, and there is a walker which travels in this segment. So classically we would say that there should be uniform distribution inside the segment. Yeah, so classically we say that the probability of finding this object is uniform. However, in quantum mechanics, it's sign square. It's completely different probability distribution. So now our object should be localized in the center. Yeah, so it's completely different behavior. And to get the sign square, we can again assume not uniform ensemble of single steps like this Drunken-Sailor, but instead of entire trajectories. Doing so for half trajectories from now toward past or from now toward future, you'd get the first power of this sinus of amplitude. But if you use full trajectories, in a given moment, both amplitudes have to meet. Yeah, so this one propagator and second propagator each gives one probability, and now to get some value, we need to get it twice from the past and future propagators. So this way we get the square, we get the Born rule, exactly from time symmetry, like in this S matrix at heart of quantum field theory. So this random walk is also called as maximal entropy random walk. Okay, so and can be this maximal entropy random walk is also along Ising sequence. So let's think about this Bell variation. So some simplest inequality of this type is called Mermin's inequality. That tossing three coins at least two give the same. Yeah, so this is completely obvious, and it can be mathematically written like this. And let's try to show it. A simple proof. For simple proof, there are 8 possibilities, and this inequality corresponds to this for once. Yes, that A and B had to be equal. For this, among these 8 possibilities, there are 4. Plus this form, plus this 4, and if you sum it, everywhere is at least 1. So whatever probability distribution on these 8 possibilities we choose, this has to be at least 1. Yeah, so we have this inequality. We have just shown this inequality. But for that, we have used this Kolmogorov third axiom. The probability of alternative is just sum of probabilities. In contrast, quantum mechanics allows to switch it to Born rule. Different answer to the same question. Yes, if you do it, let's look at this amplitude. So just replace these trees with zeros, and using them with Born rule, we get variation. So no longer above 1, but just 0.6. Yeah, so deriving inequality using the Kolmogorov axiom, then replacing it with Born rule, it's not a problem to violate the inequality. And as mentioned, it could be already done for Ising model. So we have a sequence of spins. So let's imagine that we have a sequence of three spins for this inequality. So if you would ask for the probability at the end of this sequence, we would get these amplitudes, this 1/6 probability among these 6 possibilities. But if you ask about probability inside, again, the two propagators have to meet. Each brings this 1/6, and we get them the squares, the Born rule, which allows to validate the inequality. Yeah, so this is absolutely crucial that we use this Born rule, which comes from symmetry times CPT symmetry, and it replaces the Kolmogorov axiom, allowing to validate the inequalities. So showing that we should use the analyzed block universe, not this naive presenties, which have Kolmogorov axiom, and they say that it cannot be local realistic because of Bell theorem. So, but it cannot be local in this three-dimensional case. It can be local in the four-dimensional. Yes, that in a given moment we meet two propagators, and now there is no problem, but it's super deterministic. So, but it's crucial for Bell inequalities. It's absolutely crucial to use this four-dimensional philosophy of time. Okay, so let's look at some concrete experiments. So in quantum mechanics, looking like using the retrocausality. The classic ones are a Wheeler experiment, that if you have a photon and it could go one or the second path, so very far away, like one light year away. So depending on what type of detector we use. So if we use detector distinguishing the positions like telescopes, or detectors which don't do it. So so one of them is classical. If we distinguish, we get classical statistics. If we don't distinguish, we get quantum statistics. Yeah, so it's completely different behavior. But we make this choice much later, like it was like 1 year later. Yeah, so this choice between classical and quantum behavior was made a year earlier than we make this decision. Yeah, so much later we made the decision, and it looks like influencing the past behavior. So it was realized in much simpler setting, in the Max Zender setting by Aspects group in 2007, I think. Another type of experiment are famous the quantum erasure, the light choice quantum erasure type of experiments. The nicest of them is I think that is the Walborn's realization, that he get them entangled photons, and now rotating polarizer in one arm, he changes the statistics between classical and quantum for the second arm. Yeah, so naively, just making this first arm longer, we could set information back in time. Yes, because it would be earlier by this light path. However, it's crucial to use the coincidence counter to check that indeed there are two photons, and doing so, we cannot send information back in time. Okay, so there are also less standard experiments. So one is 2003 experiment that having calculated the delay for going through some rubidium cell, and they get, for some parameters, they get negative delay. Yeah, so already in 2003 they get negative delay for going to rubidium cell. And recently there are a lot of news about this Steinberg's similar experiment with negative time, that he has one impulse laser, so very short impulse, looking like photon, but these are not exactly photons here. And then there is a probe continuous wave measurement. And now they look, so here is the impulse, and then sound that there is response already before the impulse, both after and before, and with and without post-selection. So in fact, this post-selection, also without post-selection, there is some dependence. So indeed, so it looks like the system already responds before the impulse. So their explanation is that the photons spend negative time in the rubidium atom, what doesn't make much sense. So yes, so that the photons go here and then go back in time, then go forward. So I don't think it's physical. Instead, much more physical is just saying that we have this four-dimensional case. So the causality can be speed of light, but can be forward, but also backward. So there is just coupling of two the resonators. So instead of going back in time, I think it should be just CPT analog of absorption. Yeah, so instead of causing absorption, this is CPT analog, so this is causing stimulated emission. So getting a negative delay. So I think this is the more appropriate explanation. Okay, so let's think about some applications. So one of them is two-way quantum computers. So based on this symmetric formulation of quantum mechanics, quantum field theory. So it's not a problem to get two-way control for electronics. Here we have a chip, we connect it to battery, and this way we both push electron into this chip before the calculation and also actively pull from this chip after the calculation. Yeah, so we kind of anchor it in the past, in the future, the calculation. Yeah, so we have two-way control. But if we could do it for quantum computers, such anchoring from both time directions, then we could they could be much better. So better error correction, better resistance to error, but also could attack so-called post-BQP problems which contain NP. So this way it might break most of the current ciphers. So I think it's we should consider this possibility because we might need better ciphers. Yes, so the question is how to get quantum version of this two-way control like for electronics. So for example, for hydrodynamics, we also have a pump. We both push into and pull from. Yes, we have two-way controlling from past and future this behavior through this chip. So they start working on superfluid-based quantum computers. If so, just connect it into the pump, we should get two-way quantum computer. In theory, are able to break most of the current ciphers. Or if you can do it with hydrodynamics, which is very similar to electrodynamics, maybe you can go to electromagnetism and for photonics preferably. So the question is how to get a pump for photons. So I think there are very nice experiments with using two semiconductor diodes. So one is positively charged for emission of photons, and the second is reversely charged. So it has tendency to absorb. And turns out indeed that the reverse bias of the second diode improves emission from the first diode. This way they get super radiance in this article and further. So we both push photons and pull photons. So just putting our optical photonic chip between, we should get this two-way control. You should like for pump, we should actually pump our photons to this chip. Yeah, so this is the most promising direction. Just use this opposite biased diodes and a photonic chip between them, and we might break most ciphers maybe in some near future. Okay, so also the general relativity treats time completely as just for dimension. Yeah, so you can do magic in general relativity, starting with this rotation of time to space below the black hole horizon. Yeah, literally our time switches with space below horizon. So this is one magical possibility, looking like and requiring this eternalis block universe. So thinking about evolution, it's completely different. So we need to find a four-dimensional solution already, yeah? So which includes all this behavior. So besides black holes, in theory, there are also allowed wormholes, which can connect one point in space-time with another point in space-time. If it's real, then we could send information back in time by so-called closed time-like curves. Yeah, so having those closed time-like curves, again, you could make computers which can solve NP problems, no problem. So again, maybe we should rethink this. So there are some articles, especially recently, about some communication by satellite. And finally, for wormhole, in theory, we could be Klein-Bottle-like, that it can reverse this direction. So we travel through such wormhole, and it literally reverse the light cones, past and future light cones. So this way, our time inside the rocket would be reversed in contrast to the outside time. Yeah, so flying through such rocket, our entropy would grow in the opposite direction than outside, and so on. We would get this post-preparation of the quantum computer would be switched, and so on. So they are not realized in nature, but if they are allowed by the theory, you should at least consider such possibility and think about its consequences. Yeah, so it's very valuable, I think, thought experiment at least. So another view on this time symmetry are the retarded advanced waves. But if you have Maxwell equations or gravitational wave equations linearized, then if there is a solution for a wave, there is always plus minus, there is symmetry. Yeah, so the delay can be positive or negative. So positive delay means retarded solution, but the negative is called advanced solution. So symmetrically cause going not forward in time, but backward in time. But as mentioned, there is this asymmetry of radiation, which makes there cannot be the same contributions. And for example, there is this famous Rosen article claiming that questioning existence of gravitational waves. Now we know they exist and are measured, but exactly because of this advanced wave, because he assumed there is one half contributions. But instead, we should use, I think, this asymmetric radiation to say that we should at least consider different contributions, like 0.99 retarded, 0.01 advanced. Yeah, so the question is, for example, for this gravitational wave, if there are only retarded or maybe both. So why for electromagnetic is more complicated, because the CPT symmetry changes emitter with receivers. For LIGO just measures length, and length is invariant for the time symmetry. Yeah? So if you just reverse time, the length is the same. So if there are advanced waves, then LIGO should see them. Yeah? So now the big question is, if given event is retarded, observed event is retarded or advanced. So they automatically assume they are retarded, but I think we should at least verify this assumption. And there are many arguments that there might be also advanced. So one is that among like 400 events, there is only one electromagnetic counterpart, which is so for this one event, we can be certain it was retarded. But what about the remaining 399? Yeah, so and finally, if having an event which we are certain that should have this electromagnetic signal, but telescope say that there is nothing there, then we should consider it might be an advanced event. Another argument, there are two events. Like there are some events where both the black holes of these events would have to be already from merger, and so it needs much more time. So it's surprisingly early. So maybe it was not retarded event, but advanced event. So it would give it much more time to happen. Finally, there are also these pulsar timing arrays, which they say they see vibrations of the universe. And they say they are caused by supermassive black holes. However, they say the number is insufficient, because again, they only consider the retarded aerial supermassive black holes. But maybe there's symmetry. We have these four-dimensional membrane space-time, and now if there's something happening causing these ripples, it should be working both time directions. So again, so maybe they should also include the advanced supermassive black holes. And so finally, so here is some summary. While there was this belief that the space that universe is accelerating in expansion, in recent year there are a few counter arguments, so we should rethink it. So it might be that it will finally collapse into the point. But so let's try to assume that there will be this big crunch. And this situation there, from thermodynamical perspective, is very similar. Yeah, so just some very dense soup, everything is in one place. So entropy should be the same. Yeah? So entropy here and entropy here should be practically the same. So evolving forward in time, here we get entropy growth, and we could also evolve backward in time, the CPT symmetry view, and again we should entropy growth in the opposite direction. Yeah, so it suggests that entropy should be also cyclic. Yeah, so if so, why we don't see some low entropic artifacts from here? So probably because there is a large, long age where there is very high entropy, so nothing will survive them. Also, there is this asymmetry of radiation, as mentioned. So now electrons are mostly emitting, circulating, and also masses, because there is more absorbers than emitters. But in the future, it could be reversed. Yeah. So finally, in the center, our electrons could be in equilibrium, emit and absorb nearly the same, and then the opposite. But for this reversed observer, it will be as it should be. So finally, one type of artifacts which might survive this heat death equilibrium might be a black hole. Yeah, so our black hole might survive to this big crunch, some of them at least. So also thinking this backward in time, there should be also this tendency to form black holes, but for us it would be white holes. Yeah, so maybe also some of these white holes could survive to our times and be some very lone shining points. So I think we should at least consider that there are these tiny red dots. Maybe some of them might be white holes, but the big question is what spectrum to expect. But I think we should be open to possibility of white holes, especially from here. Thank you for the attention.